Okay, good afternoon, everybody, again. So the first little recording is separated, luckily for you guys. Just you can watch that. Let's take answers. 2005 paper. Question number 1, answer 4. 2, answer 3. Manjula, 3, answer 4. 4, answer 2. Nadichara paper answering sheet. 5, answer 2. 6, answer 3. 7, answer 5. 8, 1, 9, 4, 10, 5, 11, answer 2. 12, answer 3. 13, answer 5. 14, answer 4. 15, answer 2. 16, 1. 17, 3. 18, 4. 19, 4. 20, 3. 21, 3. 22, 4. 23, 5. 24, 2. 25, 3. 26, 4. 27, 5. 28, 305. 28, 305. 29, 4. 30, 3. 31, 5. 32, 3. 33, 4. 34, 4. 35, 2. 36, 1. 37, 2. 38, 3. 39, 3. 40, all. 41, 4. 42, 5. 43, answer 5. 44, 4. 45, 5. 46, 5. 47, 2. 48, 5. 49, 4. 50, 3. 51, 3. 52, 3. 54, 3. 55, 5. Sorry. 53, 3. 54, 5. 55, 3. 56, 1. 57, 2 answers, 3 and 5. 57, 3 and 5. 58, 5. 59, 5. 60, 1. Okay, so you guys have written your answers on this answering sheet. Everybody on here. Am I on here? Louder. You didn't do the paper? Okay, you guys have to do on this paper because you need the practice. Some students are saving this one and writing answers somewhere else. Don't do that. If you want, you can request another one from Manjula. Writing on this one is again a training. You need that training as well. You are answering, supposed to be marking on the answering sheet. I'm not asking how many are correct. Maybe a couple of more. This out of syllabus stuff can be here. So let's go through the questions. Then once we're done discussing all these 60 questions, we're going to go through how many corrects and also going to write your review as well. Going to write your review then. Okay. Question number 1. Third ionization energy highest. See the resemblance for the last paper. Those always very easy. So top element in group 2 Anyway, they were given just one single. Highest the ionization energy goes to the second group. So answer is magnesium. Question number 1, answer 4. Question number 2, carbonyl carbon. So CC 0, this side +1, 2 minus, -1. So the answer become +1. 2, answer 3. If your answers are wrong, if you have anything to discuss with me, just disturb me, because I'm not looking at you that much. I'm just looking at the screen here, because I want to finish everything before 12:30. Okay. So the next one, increasing order of acidic strength. CH3OH leaves acidic because this is providing electrons onto OH with this inductive effect of CH3 group. H2O doesn't have inductive effect, so acidity is greater. This one, this lone pair is delocalizing on benzene ring, and also the formed phenate ion is also more stable, so that more acidity with more electronegative oxygens, greatest acidity. And here I have written this evidence why these are saying more acidic. If you feel like this question is harder, go through the acidic summarization of the summary I have given. I have given the summarization note, short note. Go through that. 100% knowledge is there for all these compounds. Question number 3, answer 4. Question number 4 does not occur when going down the group. Metallic character. See, antimony, bismuth are metals, so metallic character increasing. Hydrides become less basic. Yeah, when you're going down the group, these are Lewis bases. Going down the group, size is larger, can delocalize within the ring, atom, molecule. But in nitrogen, it's harder. Nitrogen is smaller. So as a Lewis base, this is providing more electrons. So hydrides are become less basic going down the group. More reducing, going down the group, electronegativity is decreasing. So easy to oxidize very easily. H plus converting hydrogen to H2, H plus to H2. So acting as reducing agents very easily by reducing other species. Oxyacids become less acidic. Yeah, going down. So more acidic. These are basic. So become less acidic. Oxides become more acidic. That's wrong. So become more basic, because down there you have metals. Metals are not acidic. Those are basic. Question number 4, answer 2. When I'm explaining things, concentrate really well on this. Then, hello, charge me. Sir's phone. Okay. When I'm explaining things, concentrate really well, analyzing yourself, because you're going to write the self-review after doing this, same as 2000 paper. How you're going to write your review to avoid these errors for the next paper. Analyze yourself doing this. These are the things, otherwise, these theory are really, really easy. You can understand theory really nicely. Analyze yourself, how you're going to avoid mistakes and how to reach 100 marks. Regardless your first shy results for revision students, you are reaching 100 marks. I have done that. I can do this for you. So don't worry and just concentrate here. Base strength. So amide, this CO is dragging electrons away. So electron density is less. But benzene is providing electrons. But at the same time, this lone pair is delocalizing within the benzene ring. So that less basic. No delocalization, more basic. Through the inductive effect, basicity is increasing. Question number 5, answer 2. Question number 6. Ideal solutions of 2 volatile liquids is correct. A boiling point of an ideal solution of a given composition is a constant. Yeah. Ideal or non-ideal, as long as composition is constant, boiling point is constant. When an ideal solution is distilled, its boiling points, yeah, So more volatile one is going more to the vapor phase. So boiling point of the distillate, so that is increasing because less volatile one is remaining in the flask. Ideal solutions can occur only over limited range of compositions. No, all compositions, whatever it is, all proportions. When you are drawing these curves for ideal solutions, we are going from either 0 to 1 or a fraction or 0 to 100% if you go with the percentage. So any composition is true. All ideal solutions obey Raoult's law. Raoult's law is made for ideals. Boiling point of an ideal solution lies between, if you draw the curve, this is the total mixture's boiling point, then it is always in between the lower one and upper one. So this is the range. It's always in between those two. That's again true. So that question number 6, answer 3. Question number 7. Question number 7. Which of the following compounds does H2O2 reacts as a reducing agent? H2O2 becoming a reducing agent, so it's supposed to go through oxidation as a reducing agent. It's supposed to go through the oxidation, so it's supposed to make this O2. Then if you consider all these, the one which is making the O2 is this one, only this one. So that question number 7, answer 5. Go with the recording again, maybe twice, maybe 3 times. Then if you feel like something is missing, write these equations and get the practice. You guys need that practice continuously for a couple of times. Question number 8. Has the largest dipole moment. All the other dipole moments are 0. So even larger or smaller, anything which is having the dipole moment, it is only answer 1. 8, answer 1. 9. The colored salt that gives a colorless solution in hot water, that's lead chloride, bromide, iodide. Lead chloride, this white needles, lead iodide, golden plates. Question number 9, answer 4. Arham and Rusiru, just sort out all your problems, get to the class to write the paper, not for the discussion. You must come to the class to write the paper. Question number 10. One of 2 ideal gas bulbs is filled with X moles of same number of moles of, one is ideal gas and the other one is real gas. Correct statement is asking, volume of the 2 gases are equal because they are identical, so same volume. Pressure of the ideal gas is never smaller than that of, real gas have more intermolecular interactions, so less pressure. Ideal gas pressure is always high. 2 gases may become equal. Let's say when you increase the temperature, less intermolecular interactions, so 0 intermolecular interactions. So it is reaching more towards ideality. So there can be that pressures that both gases have same pressures. Compressibility of 2 gases may become equal. That's the same thingy. When you increase the temperature, less interaction. So when real gases are become more closer to ideal, that compressibility factor become 1 or equal to each other. The mean gas speed of the 2 gases are equal at any temperature. That depends on the C squared Y equals T RT or M. That depends on molar mass. 2 different gases mean 2 different molar masses. So that this is changing. M is different, so C squared Y is changing. What is your answer? Are you okay now? Remember that we discussed in a container, if you have real gas, when it is trying to collide, so all these molecules are dragging it back to the middle. So less collision, less pressure in real gases. Okay, question number 11. This is extremely easier. Answer 2. If you feel like it's complicated, or if you have a question, just ask me. Easy questions I'm just going on because we have a lot to discuss and I don't want to waste your time. I mean, you should know that some of these people are doing one single paper for 4 days. I have my experience, like some individuals also does that. Like they get 4 days to complete one single paper, and for individuals classes, it's like, you know, maybe 20,000, 25,000 and so on, just to complete one single paper. So concentrate really well and get the benefit. I'm giving this maximum benefit to you guys. I don't do that. Okay, which of the following statement is incorrect? Wrong statement is asking. I get the reflection of this light. Okay. Question number 12. Which one of the following statement is incorrect? Wrong one. The element at the top of the electrochemical series are most reducing. This is the secret. If you go through the electrochemistry part is extremely easy. Please complete it this week. From next week on, you would feel free about electro. Top one is always anode oxidation. That's actually negative. Bottom one is cathode reduction. That is positive value. So top elements are oxidizing easily. If you have zinc and iron, zinc is more oxidizing. Zinc is more active than iron. Remember the cathodic protection. So you have to remember this one, like zinc is in the top of iron. So second one is also correct. Elements above hydrogen in the electrochemical series will liberate hydrogen gas from acids. Yeah, elements below hydrogen only with strong acids or oxidizing acids. That's again a memory. The oxidation state of an element of a compound can be 0. Yeah. See, I have given 2 examples for you guys. In these 2 examples, this middle element oxidation number, carbon's oxidation number is 0. This one we did at the class, remember, for unit 2. Cl2 will liberate I2 from a solution of KiO3. That's impossible because both Cl2 and KiO3 are strong oxidizing agents. Both cannot get oxidized. So oxidizing agents are getting reduced. The other species is supposed to be oxidized. So it is going this way. I minus is oxidizing to I2, not Cl minus is oxidizing to Cl2. That's again the question of the electrochemical series. Question number 12, answer 3. Amaya and Nadija, you would feel like it's stressing because you have, did you guys read the question? No. Yeah, that's what. I want you guys to go home and forget this, then do the paper separately, then listen this again, okay? The correct standard enthalpy formation of atoms of these 4. Let's go with bond energies. Nitrogen-nitrogen bond energy is the largest, so it needs more energy. Then this is a double bond, and Cl-Cl single bond. And see, the neon is inert. There is no formation enthalpy, so that's supposed to be the least one. 13, answer 5. Who's incorrect? 13. Correct? Incorrect. Why? Oh. Okay, question number 14. Which of the following statements not true regarding chromate and dichromate? See, the both oxidation numbers are +6. Both contain chromium in its highest oxidation number +6. Yeah. Both oxidizes I- to I2. So this is chromate, this is dichromate. Both converts I- to I. What is I2 here? here plus I2. It's supposed to be 3I2, okay? Then third one, they are in equilibrium. Yeah, that we know that we did for equilibrium many times. This one, both gives precipitates with ammonium hydroxides. Fifth one, both are reduced to Cr3 plus by SO2. So those reactions are again true. We can with SO2. This is become to Cr3 plus. SO2 is converting to SO4 minus. And remember that we are doing this redox reactions in acidic and basic conditions. If it is making hydroxides with ammonium hydroxide, then how do we do this, perform these experiments? And the other thing, these are chromates and dichromates, no precipitation. But once it converts to Cr3 plus here, then if the OH- is concentration enough, then they can make the precipitates, not chromate and dichromate, but Cr3 plus. Okay, then question number 14, answer 4. Question number 15, largest contribution supposed to be this propagation. This is wrong, no anion and cation. First one, no anion cation, that's wrong. Then third one is a termination. Fifth one, no formation of these hydrogen-free radicals. And again, cation are here. That's wrong. There are no cations making. This is a propagation method. Chlorine is a free radical here. Question number 15, answer 2. 16, not true regarding periodic elements. All elements which one valency electrons are metals. Hydrogen is a non-metal, so that's wrong. There are metals as well as non-metals in group 4. Yeah, carbon, silicon, non-metals, tin, palladium, those are metals. Most elements in group 3 are metals. Yeah, aluminium too, gallium, indium, thallium, all are metals. All, nanti cakap dah? Kaatද? තියන්න හිමින්ද break එකෙන්. දැන් මම මේක fast කරන්න Saturdays. All 3D transition elements are group 7 contain elements. Yeah, all three. These three physical state. Those are like old stories for now. Question number 16, answer 1. Question number 17. We have this. Yeah, I've seen this. Manjula, what am I having this? The light take up. Make it a light take a reflection. I can only cover make with the one. Make her. Are you guys okay like this? Are they married? Okay, question number 17. They are asking correct order of boiling points of these 4. Okay, we have 4 different conditions. Pure water, water sugar, ether water, and coconut oil water. Okay, first part, non-volatile part I'm going to go with because sugar is non-volatile, coconut oil is non-volatile. Okay. By dissolving a non-volatile solute, what happened to the vapor pressure? Vapor pressure of solvent is decreasing. That is called vapor pressure depression. So, considering the solution and solvent, solution's boiling point is greater than solvent's boiling points. So that if you go with the pure water, pure water boiling point is now less comparing to sugar mixture. So out of those two, we can get here P is less than Q. Then we are moving to this, that is a miscible part. Then immiscible, we cannot apply Raoult's law. Then we are applying the Dalton's law of partial pressure. This is the second time we are explaining this, isn't it? Not the second time. I think we did this for theory as well. This is the third time. Okay. Then if you go with the Dalton's law of partial pressure for immiscible, then total pressure equals saturated vapor pressures of water and ether. So that total pressure is greater than saturated pressure of water and ether separately. So that the boiling point of mixture is supposed to be less than boiling point of water and boiling point of ether. That is the one thingy. And then volatility. This is from your general knowledge. Ether organic compounds are very volatile. And then water in the middle, coconut oils are very less volatile. So that the boiling point goes as coconut oil the greatest, then water, ether's boiling point is the least. So that the lowest boiling point goes if, because both are volatile, are, then the highest boiling point, sugar and water, is non-volatile. Sugar decrease in the volatility, so it's Q. So that it is going this way. Question number 17, answer 3. Is that clear? Question number 18, answer 4. Do you want an explanation? If when I'm just saying the answer, I have the attitude that you guys got this correct answer. Let's say that you have done some sort of a mistake, so your answer is wrong, then just disturb me, okay? Please disturb me. I'm expecting you guys are disturbing me. I want you guys to disturb me. Question number 19. This is the group 2 is, first we are boiling. We boil to remove H2S. Then we are adding nitric because we need to convert oxidize Fe2 plus to Fe3 plus. Then we are adding ammonium hydroxide to give this basic condition. We are adding ammonium hydroxide together with ammonium chloride just to decrease the hydroxide concentration. So the compounds with less Ksp can get precipitated. Question number 19, answer 4. Question number 20, answer 3. Those questions I'm just going on, okay, easy questions. Question number 21, answer 3. Because you guys are now well improved, that's why I'm going this way, especially for first try students. If you feel any uneasy, just disturb me, okay? 22, answer 4. 23, sodium hydroxide reacts with urea as follows. Okay, they are giving this they are giving this balance equation, stoichiometrically balanced equation. Urea to sodium hydroxide 2:1. They were taken 0.6 grams of urea, 0.6 grams of urea. Molar mass is given as 60. You can divide by 60, so you can get number of moles. Reacting with CV of sodium hydroxide, they were given the CV of sodium hydroxide. That is 1 into 25 into 10 to the power minus 3, altogether 25 into 10 to the power minus 3. That's the total sodium hydroxide. Then it is making this ammonia, they say they remove the ammonia. To neutralize this total mixture, CV of HCl is asked, a volume of HCl is asking. Okay, to get the volume, we are supposed to find this total number of moles of HCl. Anyway, so urea is 0.01. Then twice of urea needed sodium hydroxide, that is 20 into 10 to the power minus 3. And then the stoichiometry between urea and sodium carbonate is 1:1. So that same amount of urea is forming as sodium carbonate. When you are adding, now urea is finished, no urea. When you are adding HCl, both sodium hydroxide and sodium carbonate reacting with HCl. Let's find out how much HCl needed to sodium hydroxide, how much HCl needed for sodium carbonate. This is the used amount. This is the total amount. So that remaining amount is the difference between these two. That is the 5 into 10 to the minus 3. And sodium hydroxide to HCl is 1:1. So that HCl, sodium hydroxide number of moles supposed to be exactly the same. And then sodium carbonate to HCl, let's assume that total sodium carbonate has reacted with HCl. Then the ratio is 1:2. So sodium carbonate is 10 into 10 to the minus 3. Then twice of HCl needed, and that is this much. So the total HCl is 5 into 10 to the minus 3 and 20 into 10 to the minus 3. That is 25 into 10 to the minus 3. Then if we divide that number of moles by the given concentration, we can get the volume. So VHCl equals 50 cubic centimeters. So question number, what is that? Question number 23, answer 5. Going to question number 24, correct order of bond angles. For that, again, we are going with this Lewis. Question number 24, answer 2. Can I go like this? Is it clear? Do you want me to explain this drawing Lewis and then shapes, then bond angles? 25, answer 3. Any explanation, anybody? Saptala. What is your answer, Dhoni? Okay, Saptala, explain why the answer is the third one. – 25th. Start from ammonium. Start from ammonium. Ammonium has 2 pluses. Tavasara. This is supposed to be 2 pluses. Then this is supposed to be 2 minus. Got it? That's where you're supposed to go. Tavasara. Question number 26, they are asking different equilibria. There are supposed to be 6 equilibria. Question number 26, answer 4. Don't go with the memory that we did at the questions. You have to write this again, okay? You have to write whenever we are doing a question, just considering that the question that we already done, forget that memory. Then do this as a fresh or new question. And whenever you are going with the new, did question, like the question with experience, try to find out mistakes that you have done earlier. Don't go just with the answer. Question number 27. Largest change of pH when you're adding 1 cubic centimeter of 1 m sodium hydroxide solution to each of them. So the first one is acetic. Acetic with sodium hydroxide, sodium acetate. Let's say one was adding, one is neutralizing. So let's say remaining acetic is 19. 1m19 divided by, now the total volume become 20 plus 1 to 21. Then concentration become 0.9047. Initially 1, now 0.9. So the difference is 0.1. I have just shown that because you need to get a little idea. Second one, no difference. Third one is buffer, so that no difference. Fourth one, H2SO4. Okay, same as this one. H2SO4 is again going same as this one. 1 cubic centimeters neutralizing, but 19 is remaining. But if you go with water, sodium hydroxide 1 m 1 cubic centimeter, so the number of mole is 1 into 10 to the power minus 3. Total volume become 20 plus 1, 21. If you divide moles with total volume, this is the concentration. Get the pH. pH is 1.3. Initially 7, now 1.3. So it is 5.6 each difference. If you feel like you don't know how to do these questions, usually, not always, next time they can be add extra something. Concentrate really well. These are all questions, but highest difference goes with water. Highest difference goes with water. So that question number 7, answer 5. Question number 28. I don't understand what you're saying. Yeah, what is the meaning of amphoteric going from base and acid? They can act as. Yeah. No, amphoteric with water. I mean amphoteric with water. Oh, that's you have to consider as a reaction. Yeah, that's what I'm saying. Yeah, that part, if they add something extra, let's say they're adding an amphoteric to this mixture, then whether it's acidic or whether it's basic, then what is the reaction? You have to think of those. Okay. Gives precipitate with sodium hydroxide, precipitate with ammonium hydroxide, where first one is insoluble and second one is soluble. Okay, we have 5 different compounds. Aluminium is dissolving in excess, making the sodium aluminate, it's amphoteric. Chromium is also possible. You can say this sparingly soluble in sodium hydroxide, but it makes both these precipitations. And this is also soluble. Or zinc you cannot get, again this, it is making sodium zincate. Iron, you guys know, with the ammonium hydroxide, it is only make the precipitate, no solubility. Ferrospheric manganese story is different. Copper is also possible. Cupric hydroxide, no reaction with further with sodium hydroxide, but this cupric hydroxide with ammonium hydroxide, it is making this precipitate, this aqueous solution. Let's say that they were not given copper 2+, then your answer is supposed to be Cr3+. Anyway, the best answer they were taken as 5, copper. Question number 28, answer 5. Question number 29. One test tube has hexine and 1 hexine and 2 hexine. Sorry, 1 hex, yeah, hexine and 2 hexine. This is terminal. 1 hexine is terminal. So the answer is this. Answer 4, ammonic acylnitrate. Terminal alkynes. A best possibility is 1 sigma and 1 pi. Other are wrong. These are the possibilities. Either 1 sigma, 1 pi, or 1 sigma, 2 pi's. 30 answer 3. 31, correct observation, both tests for test A and B. HCl, silver chloride possible, but H2S silver sulfide, it is black precipitate. So white is incorrect. This is correct. Barium chloride is aqueous. Barium sulfate is also precipitate. Is aqueous. No precipitation. So this is wrong. No precipitation, cadmium chloride correct. Cadmium sulfide yellow, not black. It is wrong. Magnesium chloride is again aqueous. So white precipitate is wrong. White precipitate is wrong. No precipitation because chlorine same. No precipitation, no change. But this one with H2S, this is a reaction. No precipitation and turbidity. Yeah, turbidity comes through this sulfur. So this is correct. 31, answer 5. 36, pH values increasing what is asking. I'm going with the answer. This is acidic. Ammonium chloride HCl acidic, so the lowest pH. Then D has ammonium hydroxide and acetic acid. 0.2. This is sort of neutral. Weak acid, weak base, neutral. Then C is a buffer solution, but in that buffer, it is a basic buffer because you have ammonium hydroxide. So its pH supposed to be a little greater. This is pure ammonium hydroxide, no ammonium chloride to decrease the pH. So the highest pH going to B. Question number 32, answer 3. 33. One cubic decimeter of 0.2 HCl, the H2SO4. They were given CV of both. So this is same 0.2. So the 0.2 gives 0.4, 1:2 ratio. Here 0.2 gives same 0.2, 1:1. So total become 0.4 plus 0.2, that is 0.6. But 1 cubic decimeter and 1 cubic decimeter. So that it's 2. This is the easiest way to get the answer. So it's 0.3, H plus concentration. This is the easiest calculation. So question number 33, answer 4. Question number 34. Redox reaction. Okay, see, they were given this one. Who cares that? Anyway, this is calcium oxalate. We know that. C2O4, that we know that. So, calcium oxidation number is not changing. But here carbon oxidation number changes from +3 to increasing to +4. That is oxidation. And here it's +2. That actually is disproportionation, sort of a disproportionation. Question number 34, answer 4. 35. Distinguish between amide and amines. Amide and amines. Number 1, bromine water, no reaction of both. Heating with sodium hydroxide release ammonia from amides. For amides, no reaction here. For amines, this is amide and this is amine. 2,4-DNP, both no reaction. Dil HCl, both are making these salts. And last one is KMnO4, no oxidation with both. Okay, so question number 35. Amides heating with sodium hydroxide releasing ammonia. So question number 35 answer. Just go with Dior. Violet to red, energy is decreasing, frequency decreasing, wavelength increasing. Then for the given structure, from here to here, see the energy gap is decreasing. So from here to here, energy is increasing. So you can go with, let's say, blue, green, red. So blue. Okay, I'll go with another. Green, red, blue. Let's say this one. Then green, red, then blue. Even the order is wrong. So if I go with red, green, blue, red, green, blue. So they are asking A, B, C. So A is supposed to have the lowest energy. C is supposed to have the highest energy. So if you go separately like that, going like that, so you're gonna stick to this answer. Question number 36, answer 1. As a bleaching agent, we are not using potassium permanganate. All the others are possible. We are using at times. 37, answer 2. 38, acidified alcoholic 2,4-DNP, orange precipitate, it's supposed to have a carbonyl part. Okay, reacting with nitrous, NO2 group is oxidizing to OH. NO2 everywhere, converting to OH is possible. Then oxidizing, COOH, no oxidation. This OH, no oxidation. 3, 4, and 5 are possible to oxidize. Then after acidifying, you are adding 2,4-DNP. If it is a primary alcohol like this is become CH2OH, CH2OH. If it is primary alcohol, it is oxidizing up to COOH, COOH. So no reaction with 2,4-DNP. So it's supposed to be secondary. This is oxidizing only up to CO. So that question number 38, answer 3. (39) Consider the following compounds. Pair of above will produce a thermoplastic polymer. Thermoplastic that you can reheat and reuse. Phenol formaldehyde bakelite. This has this 3D structure, so that is a thermoset polymer. That is AB mean this is phenol and formaldehyde. But formaldehyde with this compound or this acid halides with this amines CD, that actually is nylon. That is the condensation polymer, and it's also thermoplastic. And the other two are again no polymerization. Question number 39, answer 3. 40. Did I cut those questions which are out of syllabus from your one? Okay. So question number 40 is we are not doing. 41, true statements. Electrons have particle as well as dual nature. de Broglie, lambda equals HOMC. Lambda is the wave part. MC is the momentum, is the particle part. A proton is heavier than neutron. No, neutron is heavier. All atoms have electrons, protons. No, hydrogen doesn't have neutron. All ions have at least one proton. Whatever, if it is a chemical element, that's supposed to have a proton. Because proton decides what? Atomic number. Proton is a must. 41, AD correct answer 4. 42, the quantum molecular theory equation for ideal gases, PV equals 1/3 mc squared bar. True for ideal gases. C squared bar is independent of temperature. That's so wrong. C squared bar, temperature, kinetic energy, all are one single thingy. Kinetic energy, temperature, means gas speed, all are dependent of temperature. Only by the temperature it's changing. C squared bar is constant at constant temperature. Yeah, if the temperature is constant, considering a particular one system, one type of a gas, because M is also changing, that's constant. PV is constant at constant temperature and independent of a number of molecules. As long as temperature constant, C squared bar is constant. But not only R and T, PV depends also on CPV equals nRT, depends on number of molecules and number of moles. So that when the number of molecules are different, PV is getting different. So that question number 42, only B correct, answer 5. Question number 43. The problem comes here is they were not mentioning the temperature here. So we cannot go with any of these answers. So all wrong. If all are wrong, always, let's say all these are wrong. So that answer is supposed to be 5. Or otherwise, the normal temperature, tin, concatenated sodium hydroxide, NO2 converts to NH2. At low temperature, this is converted to OH. Then whenever beta naphthol adding, no reaction. So reaction comes only when you are having disonium here, then it is giving this red dye. So reddish dye is not making by anyone because it's not making this disonium. Question number 44. Which of the following can be taken as evidence to non-ideal nature of real gases? Ideal, no interaction, no volume, perfectly elastic collisions. Different real gases have different boiling points. Yeah, because they have different intermolecular interactions. Certain real gases are colored while others are not. But color is not something related to ideality. Under identical conditions, different real gases have different densities. Densities, again, this statement is correct, but we never talk about the different densities, density or the mass, because they are supposed to have different masses so that their densities are different. So, but still, it's not a difference between ideality and real because both have masses. Certain real gases react chemically. React chemically mean their energies are changing, so that we cannot say the perfect elastic collision so that the kinetic energy is constant. So D is considering as again a difference between ideal and real. Question number 44, A, D correct answer 4. 45, cannot distinguish between. We can use all these three. Litmus solution mean SO2 can decolorize, CO2 doesn't do anything. You can say that solution color is not that prominent. That's why you're not getting that one. Otherwise, you can use all these. Anyway, if C is incorrect or not, all the other three are correct. So that question number 45 cannot be using asking, maybe litmus. Answer, anyway, 5. '46. The rate of a chemical reaction increases when the concentration of reactant are increasing because the number of collisions between molecules increasing. Yeah. Fraction of molecules with energy excess in the activation energy increases. Fraction is not changing. Number of molecules, if you talk about the number of molecules are changing. That is, if you go with the number of molecules here. But if you go with the fraction is initial to total. So that is a proportionate. So initially, let's say n divided by total number of moles is, let's say, 100. Then if you increase the number of molecules with 2n, like number of molecules with exceeding activation energy, then the total number of molecules with the activation energy increase again become like twice of that. So fraction is not changing, only the amount is changing, increasing concentration, because concentration increasing means both total number and the number of molecules exceeding activation energy are increasing, both are increasing. Energy of collisions, no, temperature constant, energy is constant. Correct geometry, that's again same, because they are talking about the fraction. Fraction is not changing. So that question number 46, only A correct, answer 5. 47. Let me go with the Sinhala video. Because, no, it's here. See this one, this thingy. They were given these three. So you guys know, if these two are together, who is the anode? Who's oxidizing? Q. If these two are together, who's oxidizing? Hydrogen. If these two are together, who's oxidizing? Q. The top one is always oxidizing. So if you write these oxidation numbers, which supposed to be go through oxidation and reduction, and this +1 goes to 0. This is reduced because hydrogen and P. This one. Hydrogen is supposed to be oxidized, P is supposed to be reduced. Q and hydrogen, these two. Q is supposed to be oxidized, hydrogen is supposed to be reduced. See how easily you can get the answer. Only where is the thinking style? I'm just asking again, before you finish, come to the class next week, try to finish electron. Question number 47, B, C correct, answer 2. 48, tube well water, once you got out, due to formation of FeOH 3 times, brown color happens. Reason, ferric dissolves in water under pressure. No, pressure and dissolution, we are not talking such things. Pressure dissolution gets together when you are talking with gaseous systems. These are liquid systems, no pressure involving. Iron is represented mainly in Fe2 plus in the ground well, feeding the groundwater feeding the well. It's supposed to be the answer because once it got out, it can oxidize easily. Conditions underground are reducing. Yeah, less O2. That's why iron can exist as Fe2 plus. If underground water has enough O2, so it is oxidizing inside the well. Solubility of ferric is much less than that of ferrous. That is again true. We know that through this group analysis. That's why we are converting Fe2 plus to Fe3 plus. That is the evidence. So all B, C, D correct. Question number 48, answer 5. We have the evidence. We don't want these values. I have written the values here. 10 to the power minus 14, 10 to the power minus 28 is very, very low KSP. So dissolution is greater. But you guys know this too, this group analysis. Standard hydrogen electrode, 1M, H2 true, HCl, 1H plus, 1M, H2 that is true. These two are correct, but here less than H plus is less than 1M. 1M is for acidic, not for H plus, that is wrong. Here again, if you get H2SO for 1M, now 1 H2SO gives 2 H pluses. This is supposed to be 0.5. So that's again wrong. So 49, A, D correct answer 4. Question number 50. S is a solution of sodium carbonate, bicarbonate in water. To determine concentration of these two separately, phenolphthalein. See, if you use phenolphthalein, when sodium carbonate converting to sodium bicarbonate, it is giving the color. So sodium bicarbonate cannot get from that, only this sodium carbonate. If you use methyl orange, so sodium carbonate goes to CO2 and H2O, and sodium bicarbonate itself separately going to CO2 and H2O. If you only use methyl orange, you can get the concentration of both together. So that separately to get these two, we need one reading with phenolphthalein and one reading with methyl orange. Is that clear? So that, let's see. First, you're supposed to use phenolphthalein. First one supposed to be phenolphthalein. If you first add methyl orange, you're getting the full reading. First phenolphthalein and then methyl orange, followed by methyl orange. Or otherwise, we can do two portions. First portion is with phenolphthalein. Second portion is with methyl orange. Exactly, if you apply same condition, C and D supposed to give exactly same results. Question number 50, C, D correct answer 3. Amma and Nadija, are you guys going to be okay when you go home and do this again? Saptal, are you okay here? Tony, Uta? Rusiruam Arham, okay, I'm just maybe I want later, like, are you okay like this? Question number 50, CD correct answer 3. Okay, last, see when they're coming to 2005, they were changing the format again. Last 10 questions become this two statement question. Ethylamine does not give a stable diazonium salt. Yeah, ethylamine, aliphatic amines, automatically converting to alcohol. Nitrous as reacts with aromatic amines only. No, it is reacting, but this is unstable. That is the reason. Question number 51, answer 3. 52, under a given set of conditions, a catalyst increases the amount of product obtained in unit time. Amount of product, let's say concentration of A, divide by time, that is the speed, that is the rate. So that's true. It is increasing the rate. Catalyst alters the enthalpy. No, nothing to do with enthalpy. They don't do anything with enthalpy. 52 answer 3. 53. Greenhouse gases, CO2, H2O, CH4, N2O, NO2, ozone, H2S, SO2, chlorofluorohydrocarbon, CF2, Cl2, all those are greenhouse gases. Majority of radiations from Earth absorbs and only half is re-radiated. This is a greenhouse effect. This is a good thing. But when these molecules are more and more in our atmosphere, they are re-radiating more and more energy. So it is increasing Earth's temperature, which causes this global warming. That's why it is bad. Otherwise, greenhouse effect is a good thing. It is giving us this optimum temperature for survival of living things. First statement is true. Both these are greenhouse gases. Greenhouse gases are those that consist of carbon-containing small, no, not only carbon. Gases which affect this greenhouse effect are called greenhouse gases, but all those are greenhouse gases. Some of them do not have carbon. I want you guys to mention all these. Did you write those? Copy all these greenhouse gases. because unit 14 we are doing only under this full paper. So I want you guys to go like nicely with unit 14. CO2, H2O, CH4, N2O, NO2, O3, H2S, SO2, CF2, Cl2. And small hydrocarbons are there also. Question number 53, answer 3. 54. Two different reactions taking place at the same rate and at the same temperature. No same activation energy, may or may not. For the rates, there are different factors are involving. Concentration, pressure, catalyst, all those. So that activation energy may or may not equal. Directly proportional to activation energy, that's again not true. Either inversely or there are other factors are coming across. So 54, answer 5. 55. Let's talk about that later. Question number 55. The organic product obtained from the reaction of optically active, this is a 2-butanol. When you oxidize, this secondary alcohol becomes ketone. It is not optically active. That's true. First statement true. The organic product is a racemic mixture. What is a racemic mixture? Same proportions of L and D isomer, 1:1 or 50:50. There is no such things you can get anything like from this one, whether it's a racemic or not. So second statement wrong. 55, answer 3. 56. Cl2 gas dissolved in water can be expelled by boiling. Cl2 dissolution or gas dissolution in water is always exothermic. So dissolution is exothermic. So when you heat the system, it is going backward. So it is releasing free gas. This forward reaction is exothermic. Okay, if you heat the system, this reaction is going to backward. So releasing Cl2 gas back. Dissolution of chlorine in water is exothermic and reversible. That's true. When temperature increases, reaction go backwards according to Le Chatelet principle. That's why this is releasing. Expression is there. 56, answer 1. Got it. Let's discuss your mistakes once finish this one. 57. Copper sulfate 5H2O become colorless or white on heating. Copper 2 plus ion is reducing to copper plus ion on dehydration. That's wrong. This copper sulfate 5H2O is just converted into CSO4 plus 5H2O. Second statement is definitely wrong. Let's say this is colorless. It's not colorless. So second statement, first statement is also wrong. So that answer is 5. And they were just giving this hint. Colorless mean white. In that way, answer is 3. So they were given 2 answers. Sometimes colorless, they are going with colorless as white. So question number 57, 3 or 5. I see 58. This shape is square pyramidal, not tetrahedral. Wrong. This has 1, 2, 3, 4, 5, and 6. 6 vessel pairs, not 4. 58, answer 5. 59. Once you make any dative bonding, all 4 bonds are identical. All dative bonds are identical. You cannot separate 3 separately. One NH bond in NH4 plus ion can be identified. That's again wrong. It's not different. Cannot identify separately. 59, answer 5. Usually, in your new syllabus 2, 50th question is from unit 14. In the fermentation of glucose by yeast, some carbon atoms of glucose molecules are oxidized, while others are reducing. This is the ethanol production. some carbon atoms are oxidizing, some are reducing. That's true. The chemical products of fermentation of glucose are CO2 and this. Okay, from this one, if you get here, you can see the different oxidation numbers of different carbons. So, because it's making CO2 and ethanol, they have different oxidation numbers. Since they are making these two, some carbons are oxidizing and some carbons are reducing. So that answer is 1. 60 answer 1. Now I want you guys to go through this again. If you done something wrong with writing this one, you can correct that. But before that, see, this is from 2005 paper, and see, a couple of unit 1 questions. You guys are really comfortable with that. See, unit 2, then 6, then organic, then equilibrium. That's why I said these 4 units are really, really important. Understood? Okay, now I want you guys to, okay, go to the very first page of this one, this page, and you have space here. Somewhere on that you have space. I know this is different, your one is horizontal. I'm coming to you guys. In the meantime, I'm giving you guys like a couple of minutes. Go through this questionnaire. Whatever the mistakes you guys have done, you're going to write how you're going to improve that before you get to the next class. And make sure that you are not doing any mistakes from that part ever again. Whatever the misunderstood mistakes, you are writing. That is your self-review. How I'm going to improve myself. Just write those. Okay, online students. Online students, just if you feel like you don't want to see others your marks, then WhatsApp to my phone. WhatsApp to my phone, not to tab. Okay, you can WhatsApp to my phone, or otherwise you can write on the tab. We are writing from answer to your own mistake. To your own mistake. Never be mistake. Not just Manjula. Oh, as it yeah, so I will tell you. That's all that means. Oh, that's seriously. Your own spirit. They were always kind of asked, they were like honest. And they were one time after their own school was first. So they had to question. About how would you feel? Yeah. Do you think how was it? Yeah, because I'm a big fan of this. Yeah. Okay, online students. Oh, yeah. Okay, I mean, the next day on because yeah, wow. Saranya, good. And Afra's marks. No, it's not. Yeah. Afra, I got it. Wow. Well done. Well done. Okay. Highest is 50. And my best students of class, this close by years, Deepna 50 and Nimri moving both, like they were became district fifth or sixth, I guess, 51. Harmini 42 and Zara, my best student in 2023, she got 49. So compare these marks with your marks and have the faith that you guys can improve. One totally depend on you how many times you are doing all these. I asked you guys to go as a circle, like going, you need to organic, inorganic equilibrium. You need to organic, inorganic equilibrium at the same time. I'm just reminding what Deepna said. She said that organic and inorganic, these two short notes, she was keeping everywhere. Like she was continuously reading them every day, like 4 or 5 times, because she had a couple of these separate these copies. She was keeping one in her pantry, one in her bedroom, and one in her car, and everywhere. So if you do that way, just when you're going on with something else, or when you're just going one thing to another thing, she said, so when she is going to the pantry, she is reading the note and she's just keeping it there. When she's going to, let's say, when she is traveling, then she's reading the one in the vehicle, then just she's leaving there. She has a little file in the vehicle, so she was adding all these like things that she has to memorize. So without effort, without wasting time, that is the best method that you can memorize things. And this week, whatever the mistakes you have done, you're going to improve through that whole week until this next week is this 1st August. Until 1st August, just continues to do whatever these improvements. So when you're coming the next class day, least you're supposed to increase. I don't expect you guys to go like, this time my marks is 20, next time it's 30, then the next paper is 40, then 50. I don't expect that. Let's say we are doing 20 papers. If you can improve 0.5, that's more than enough, Abusara. 0.5 mean 20, you're going to gain 10 marks. So let's say you are in our questions, let's say you are in 40, then you are going to 50. Let's say you are in 35, you are going to 45, more than enough. I want you to secure your A pass. To secure your A pass, you're supposed to get at least 42 out of 50. 42 out of 50 to get a good A pass. Okay, then you are out of danger. But I know my students, sometimes they say their MCQs are like 37 or 38, but still they get A pass because they are scoring from the second paper, because I'm pushing you guys to do this second paper as well. And then the other thing, see, I have made my own, I'm not showing this one because I don't want you guys to see this. That's why I'm not posting it here. These years. So I have made my one. Then you're going to make your own table. How are you going to make your table? You are making your own table. Like on table. Years and then attempts. Years and attempts. Then years and attempts. 2000 paper. What is the meaning of first attempt? Let's say 1, 2nd, 3rd, 4th, 5th, and so on. What is the meaning of first attempt? First attempt mean, let's say this is 2000 paper. You're going to do MCQ structured as an essay, everything once. Then you can tick here. Then, once you finish all MCQ structured essay, you are done here. Third attempt, you are done here. Then let's say 2000, the next paper I was when is 2004. Then today we did 2007. Midweek you are doing, today we did 2005. Midweek you are doing 2007. Then another one. Then if you put all these ticks, That is the confidence. Then you know I have done everything. I deserve a good A pass. So do this. Stick this somewhere. Then you know I have to do this and that. I'm not done with this and let's say 2005 paper is a little challenging, but you were still doing only once. Then you know you're supposed to fill this part. Have the communication with this. Clear that. Do everything I'm asking you guys to do. This shy is your last shy. This is the best shy that you are getting good like A pass closer to 100 marks. You can do that. Just stick to the path and do everything I'm asking you guys to do. Okay, I'm moving to structured essay. Not wasting timing because we have only 2 hours. We can do that, I know. Otherwise, I'm increasing time. I'm not increasing timing because this is more than enough and you can go home and relax and do whatever your other stuff. And if you feel like that there are stuff that you want to write, go through the recording and write that part. So you're not wasting your friend's timing because all are not in one single solution. If I give more timing to write everything, that's unfair to students who doesn't want to write. Complete each of the statement following using these compounds. Okay, if you analyze BCl3 chloride and it is electron deficient, highest oxidation number, highest oxidation number, highest oxidation number. This is, you know, the giant lattice. These are acids. H2S is a gas. H2S and H2O, some sort of a connection, you know, same group. So, and elements, boron, phosphorus, chlorine, nitrogen, silicon, chlorine, iodine. So those are these elements I have written here. That's again to make sure I'm writing correct answers. Most acidic, +7 oxidation number, Cl2O7. Don't write this 6 here. If it is not disturbing, that's all right. Otherwise, you can write down there like 6 times 6, 36 or so. Hydrogen halide showing the highest acidity. Highest acidity and aqueous solution, they were taken both. You can write any of these. HI is the best answer, but they were given marks for HCl as well. This is the radius, okay? Highest melting point, this is this heteroatomic covalent lattice, SiO2. Strongest hydrogen bond, more electronegativity difference, HF. Electron deficient acting as a Lewis acid, that is BCl3. Highest oxidation number in a compound. So that is with the most acidic one, which is Cl2O7. Oxidation number is +7. X is a non-transition element. So non-transition, either zinc or either not in D block. That is the best explanation. So, okay, not D block. Does not react with deuterium or does not react with water at room temperature. They are saying not reacting with room temperature, so it's supposed to reacting with water with higher temperature. So that definitely is supposed to be magnesium because beryllium, not room temperature, not higher temperature, not with hot water. Beryllium reacting only with steam. So this is definitely supposed to be magnesium. Only one single example is magnesium. Hydroxide of X is not amphoteric. Okay, we can rule out all the other like aluminium, zinc, all those. Zinc is amphoteric. Shows basic properties. That's definitely metal. So the element is magnesium. So these equations burnt in A, magnesium oxide and magnesium nitride. Okay, that's done. Then 4 elements, consecutive atomic numbers are consecutive. C has the highest first ionization energy. A, B, C, D consecutive. Okay, A, B, C. C is supposed to be highest. Then D is getting down. Then A, B, C increasing. C has the highest. D is supposed to getting down. So we have two different variations. This blue one and this pink one. Then the next one, D is smaller. Radius, D is smaller. Going along a period, size is decreasing. So D smaller is this one. See, D smaller. C is supposed to be greater. Hear that? So then this is group 15. C is asking, C group 15 or D greater, going down another period. So this is smaller and this is larger. This is group 1, always larger. So then they're asking C again, that is group 18. Question number 2. Sodium, sulfur, hydrogen, oxygen, percentages given. Then divide each by 100 minus 48.3. Oxygen is 51.7. Divide each by its molar masses. Then lowest number is, the smallest number is 0.8. Then you're going to get this empirical formula. 1 sodium, 1 sulfur, hydrogen 5, oxygen 4. Then the molar mass is 248. Then molar mass of empirical form is 124. So that N equals to 2. So that the molecular formula become twice of that. Na2S2H8OA, H10O8. Water, hydrogen as water. So I'm going to remove all these 10 hydrogen. So it's supposed to be then water mean H2. How many H2? 5 H2. 5 into 10, 2 is 10. So it needs 5 oxygen. Then only 3 remaining. So this is Na2S2O3, 5 H2O. And this is the lowest. Uses photography, fungicides, analytical chemistry, in bleaching to remove excess Cl minus. I couldn't find any better paper. In Sinhala one, if I go with the Sinhala one, see the Sinhala one is having these better spaces. I found a little better one for Sinhala one. But English one, I didn't find that. But your one is more clearer, I guess, because Sinhala one I have done earlier. No, your one I did earlier. That was so mess. Then the second one is Sinhala one. Then last couple of days I was using again another new copy to get this clearer version too. Anyway, so excuse for those spaces because I couldn't find any better one. No, because they were given that hint. How come you are not using that? No marks. Couple of marks. No marks here, see? They were not given marks for this one. Mention whatever the mistakes you have done and underline that again if you were not seeing that. See, hydrogen is present as H2O. Highlight that. If you miss that, highlight that. Okay. This reaction, see, 2S goes to B. Let's say the molar mass of A is X. Then what's the molar mass of B? A molar mass is X. B's molar mass? Twice. It's 2X. Hear that? 2X because they have that question asked later. And see, this is high, this is lower. From here to here, energy is decreasing. So it is, and the exothermic, delta H is negative. So this is the forward reactions activation energy. And this is the backward reactions activation energy. And they say both temperatures are greater than 100, T2 is greater. T2 is greater, so that we should know this more molecules exceeding the activation energy. Oh, in T2, this is supposed to be more and more spreading towards the right side. So if this is one single line, then this is the next line. Or the blue one. Blue one supposed to be the one which having the higher energy. This is again same. If this is the first one, then this blue one, the one which is pushing more towards this direction, having the higher energy. Okay, draw in figure 1, they want you to show this. In figure 1, draw vertical arrows to show. Yeah, see? Vertical arrows to show these activation energies. Oh, come on. See, this one and this one, I'm showing, label them as F and R. So, label them as F and R. So, this is the answer 1, not answer 3. I have shown as answer 3. Okay, then, so this is exothermic, so that the sign is negative. In figure 2, X and Y are the speeds of molecules. Identify the activation energies responding. Okay, that you guys know. R is for higher activation energy, so this length is supposed to be greater. For R, F is for lower activation energy. See, F is small, F is lower, R is greater. Oh, R here, the longer one, R here. And the shorter one, F here. Clear that? R and F. And then, that's what I said. When now 2A's need to get 1B. So the B mass is greater. So its velocity is supposed to be less, like this. See? Argon's mass is greater. So moving here, more and more less mass. So they are moving more and more to right side. So that A is supposed to be the one more is the one pointing more to this right direction, and this is supposed to be B. This is supposed to be A. Then again, if this is B, then this is B is higher temperature. So T2. If this is A and this is S, higher temperature. So these two are one which is more pushing to right. So that is this one, sorry, this one T2, and then this one is, sorry, this one, say this one. This one is T2. Is this clear? Hence, identify the different distribution that we have done that. Then part 6, delete the equilibrium concentration of A at T1, lower temperature, T1 is the lower temperature, so the concentration is supposed to be smaller than T2 because T2 is greater, and the reaction is exothermic. Exothermic, temperature increasing, backward reaction is increasing, so that A is increasing because T2 is greater. At T2, A is high. At T1 is supposed to be lower. The equilibrium, so this is the opposite of that. B is supposed to be greater than T1 than T2. When the temperature of is increasing from T1 to T2, rate of forward is increasing, rate of backward is also increasing because kinetic energy is increasing of both forward and back. To join R group to benzene, we have Friedel-Crafts acylation, alkylation, and Grignard. They were given this one here and benzene CH3. So that is the acetophenone part. They were given that. Then this one we can directly get from this one. See here. This is, then you can convert it to Grignard. Then add this part to complete this one. But this one, double bond is here away from this here. If it is closer to here, we can say we can joining a halogen, or we can go with Grignard or whatsoever. But we cannot do that because they were not given this double bond here. Double bond is here. Then this bond directly is supposed to come from what? This is supposed to come from Friedel-Crafts alkylation. Because if it is even Friedel-Crafts acylation, you can make a double bond here, then you can remove this oxygen, then you can get the double bond here, adding Cl. So this is Friedel-Crafts alkylation. For that, to get this part, this compound is supposed to be there. But it's not given, but you have this oxygen, which converts to OH and to Cl, then you can make this one from this one. Understood? So that I have to start from this one because this one is not given. Since this is not given, I have to start from this one to convert this one onto this one. See, that is a little secret. So you're starting from this given compound, propinol. So convert this CHO to CH2OH. Then this OH to Cl, all these reagents given. Then this Cl, we are adding C6H5COCH3 acetophenone. Then since this is a meta director, this CH2 double bond CH2 is joining to the meta position. Then I need to add the rest of the part. I need to add this part. For that, I'm going to convert this into Grignard so that CO converts to COH, OH to Cl, Cl to Grignard. To that, I'm adding this one to get here. Okay, this time they were given extra space to write this in 2000 paper that had as well. To write this intermediate, whenever you're writing that, plus and minus is a must. Then add water to get to here. Okay, order questions so that they were given marks. See, but still they were given 10 marks starting from this one, 10 marks. All the rest, all these reagents and middle products, they were given 6 marks. But in your syllabus, they are changing the priorities. I mean, the harder questions, students are answering less, they are giving more marks. That's sort of unfair, but fair. Correct. This one. No? Why? Because you couldn't start from here. If you were feeling like harder, this is really harder question on the students. Do this like 5 times, 6 times, 7 times until you feel, until you memorize its tricks. A and B are isomeric hydrocarbons, each having 2 sp3. 2 sp3 mean 2 of carbons with sp3 and 2 sp2 and 2 sp. Okay, they are supposed to be a 1 double bond, 1 triple bond, and 2 sp3. Again, they say A shows optical isomerism. A shows optical isomerism. So I'm going to start from that. Okay, so I'm going to start from 1 carbon 1 carbon. I need hydrogen, then 1 carbon, then 2 carbon, but still 2sp3, 2sp2, 2sp. There are only 6 carbon. So I can go with another 2 carbon. Then I know there are 2sp carbon. So I'm going to make a triple bond here. I'm going to make a double bond here. This is the very first one you are drawing. Understood? Then this is A with chiral carbon. For B, avoiding this chiral carbon, you can draw different structures. So they were given marks for any of these. Did this? Good. Good. But I'm not happy when you said that you didn't do that question. You did lots of many questions. Then a compound X molecular formula is this. Reacting, okay, potassium permanganate to give benzoic. So this is supposed to have benzene ring and something is joining here. Reacting with sodium, this is supposed to be alcohol, but the best is this Lucas, precipitate immediately, that is Lucas. So that's supposed to be a tertiary alcohol. Then carbon, 1 OH and 2 carbon. If you join hydrogens, then you can end up with the structure. The gas is hydrogen and this is the tertiary alcohol. They were given 14 marks for that. 14, they were awarding 14 marks. A lot. Easy questions. There are some papers in old, now they are not doing that. But there are no, like, the good structure, they say, oh, you say organic questions. Then you have to survive with inorganic and equilibrium. It's possible. There are no rules. They can give, like, the skipping the organic, they can add extra inorganic or extra equilibrium. That's possible. Consider the following reactions. Iodine gets away, Cn minus joins. So the reaction type is nucleophilic substitution. Then this CH2 bond addition, electrophilic addition. You are joining bromine here. This is aldol because you have disodium hydroxide, nucleophilic addition. Okay, then this is nitration, electrophilic substitution. Doesn't do anything to this one, just existing as it is. But this double bond going through the hydration, CH2, CH3. Only difference is this is from CH2, CH2. So this is other, any other mechanism, Okay, when you fill this one, these are the answers, electrophile and nucleophile. Then they want us to write this, any of these. See, if you have written this resonance hybrid, they were given 3 marks. Still, you have to show this negative part as well. Anion, or otherwise 3 marks for this and 1 mark for this. Either way, you can go 1. We are practicing with marking scheme, don't forget. 1 marks is missing. It is a must. Now you guys, that's what I'm saying, that now the marking scheme. So go with the marking. Check with marks, then you know what you're supposed to do. Like, always go with the marking scheme. At the same time, you are improving your knowledge. But my best concentration is going with the marking. Okay, shall we go to the break now? Then let's start being little fresh. Let's start essay part. Okay, time, let's say 10:45. 11? Okay, get 15 minutes break. Professor Adoni, okay, online students, give me your feedback, okay? Are you guys okay doing like this or you want more explanation? Yesterday this was good. It was 90 questions, staff like we thought. I'm going over there after this report. Mandira? Mandira? Do you guys need anybody else to give these papers? To Nalushini. Only to her. Who else? Minadi? Okay. Then they can collect. Arham? Not meeting. Rusul? Rusul is coming on Saturday. So only Arham is missing. Okay, so okay, students who are not here in the class, if you are coming on Saturdays to this bio class, you can collect this one. Today I have given, it's 2004. 2004 and 2007. These two papers, it's a must, otherwise no point of wasting our time and these giving you photocopies. I want you guys to do this one. Then the 2007 one for this midweek. Then the next week, you are coming on Wednesday or Friday here. Oh, Wednesday only. Not Friday possible. Friday okay for like from the next week on. Then you can write the next Thursday paper on Friday. If you come 2 days here this week, Wednesday and Friday, then from next week on you can start only on Fridays if you are not comfortable on Wednesday. Otherwise, Wednesday is your day to come to write the paper, and discussion was always on this Thursday. Say that. Okay. Let's say that you were not possible to come on this Wednesday, then you guys have to request that paper so that you can do it. So Nadija, will you be able to get here to write the paper next week? You guys are not coming. Okay, then ask Manjula that paper. Before you guys leaving, ask that paper. So you are not coming Wednesday to sit here, but you're coming on Thursday. But next week when it's a must, okay? Please, every other week, you guys have to get here to sit paper. Discussion is okay, but you guys have to get this experience of writing paper with me. Moving to structured essay. A and either B or C. But anyway, I'm going to do all the questions. I never go through that instructions so that. I know that when you are doing equilibrium, I feel like I shouldn't do these questions because we did these questions very recently. But I want you guys to have your own experience, especially for first try students. Don't skip any of these questions. Okay. Temperature is above 400. This A is dissociating to give B and D. Numerical values of Kp and Kc are same. Starting from these definitions, they want us to deduce the A balancing coefficient because they want us to calculate Kp because we need that for the next part. Volume given, temperature given, pressure is X. Then heating to 500, reaching the equilibrium. Then pressure is Y. And they want us to show Y divided by X equals to this. And then the partial pressure of B is Z. Then Y equals 5Z over 2. They want us to show all this. Y value, if the Y value is given, they want us to calculate X and Z. It is a little longer question. It's actually a very long question. If you get the answer for the first part, starting from the Kp and Kc, you can write the Kp expression separately and Kc expression separately. Using PV equals nRT, you can write P equals CRT. So I'm going to use Kp expression again. And then instead of P, I'm writing CRT. Instead of these pressures, I'm writing CRT. Then simplify B concentration, A concentration, this part is Kc. Instead of this part, I'm writing Kc. RT RT to the power A goes up, 1 and 2 here, so 2 minus A. Then if these two are equals, you can get this case here, which equals to 1. Whatever the power equals to 1 means, this power is supposed to be, value is supposed to be equals to 0. So 2 minus A equals to 0, so that A equals to 2. Then KP, they were given this data so that you can just substitute and get the answer KP equals to 4. C. Just check the way they were awarded marks. That is the part I want to concentrate you guys, how they were given marks, because getting these answers are, I guess, easier for you all. Understood? And this part, for the substitution, see 1 mark for substitution and 1 mark for units, then the final answer 2 marks. Then initially, so the volume is constant. Initial volume, final volume at 500 Kelvin. And then temperature initially 300 increasing to 500. Total pressure X, total pressure Y, partial pressure of B is Z. So stoichiometry is 2:1:1 because A equals to 2 now. At equilibrium, partial pressures are equal because initially there was nothing. So that number of moles are also equal, partial pressures are equal, and that's supposed to be equal. PB equals PD supposed to equals to Z. And then I'm going to go with these Dalton of partial pressure because we need to get the total pressure. Total pressure is only there. So that is PA plus PB plus PD equals to PT. But the symbol for PT, they were given as Y. And also PB equals PD equals Z. So PB plus PD is supposed to equals to Z. So that I'm writing PA equals total pressure minus these two, 2Z. Okay, now in terms of Y and Z, we have all these terms. So PB, Z, PD, Z, this is Z squared. PA equals Y minus 2Z. Then get the square value of that. Simplify, get the root value, simplify. So they are asking to subject Y. And Y equals 5Z over 2. Then Y over Z, total pressure, X is the partial pressure of, total pressure initial. See the two pressures. X is the initial total pressure, Y is the final total pressure, but they were given two temperatures as well. Then other parameters constant, just the temperature ratio is the pressure ratio. Very easily you can get that. Assumption, gases of above system behave ideally. Gases of above system behave ideally. Delta N of above reaction is 0. So whatever the given reaction, its number of moles are not changing. Because 2A and B plus D is 2 molecules, 2A is 2 molecules. Then they were given the value of Y to calculate Z. Calculating, knowing Y, you can calculate X as well. See the way they were given marks because getting answers are easier. Amaya, you didn't do any of this. Some questions you did. Essay part. Okay, it's a good thing, like rather going with these easy MCQs, going with essays. Saptala, you did this one. Answers correct. Good. Then fourth part, they were adding extra Na to the system So now why is the new pressure pressure is yeah, total pressure is now 8 into 10 power 5. Initially, but finally, once A is added, final pressure is this. To the same system, same Y. But now pressure is increasing, which relevant to this added A. So that pressure is supposed to come from that A. See, so the total pressure is the pressure of all these, but the final total pressure is this one. See, I have made this to 10 to the power 6. Then the pressure difference is supposed to be the pressure exerted from this externally added A. So that is the pressure of A. All the other parameters given so that you can calculate number of moles of A. Then there are partial pressure ratio and 2A goes to B plus T. Kp already calculated and this is 1:1. Instead of these two, I'm writing Pb into Pd as Pb squared and if you go with the root values of this, then Pb divided by Pa equals to mean Pb equals to 2Pa. Then total pressure again we calculated earlier, they were given earlier as a data. Then Pb plus Pd equals 2Pa. So that I'm writing instead of Pb, this two I'm just leaving as it is. Instead of this Pb, now I'm writing 2Pa, this 2Pa. Then altogether 5Pa equals to this, so that you can find Pa. Knowing that Pb and Pd you can find very easy. 18 marks for this part, 18 marks. 14 marks for that part, lower part is 18 marks. Because these marking schemes were really like sometimes messier. That's why I have not written marks separately. They want us to write all these definitions, equations for all these definitions. Electron gain, you are gaining 1 electron. Then formation starting from constituent elements. This is just a combustion with excess O2. First and second ionization energies. Atomization or sublimation, solid goes to gas. This is lattice dissociation for new syllabus. Lattice dissociation. That bromine gas to this Br2 to 2Br, that is dissociation. Liquid to gas, vaporization. Each answer you're going to get 4 marks. They were not expecting these numbers. I have put numbers for easiest. For to easy calculation, you can go calculations easily. Knowing those numbers, having those numbers. Then for this reaction, they want us to calculate magnesium bromide. Okay, so there are 2 different conditions then. Magnesium solid plus Br2 liquid, that's supposed to gives MgBr2. Then magnesium can make magnesium 2 plus, bromine Br minus, these two again giving this. So from coming here to here, coming here to here, and these two together making this one. That is the summary. So that I'm starting from here, magnesium solid, magnesium gas, atomization or sublimation, then magnesium plus first ionization, second ionization. I need Mg2 plus, I made it, I'm just gonna keep it there. Bromine liquid to gas vaporization, then bond dissociation, then first electron gain. So I need Br minus 2 of them. I have them. I'm gonna leave it there. Then using these two, I'm making this MgBr2. Then from here to here, that positive value is the dissociation, but here this is formation, so I'm making this value negative to get the answer. Clear that? Okay. See how they were given marks. These marking schemes are little loose comparing to our marking scheme, right? Okay, moving on. If you've gone through equation, next part, then they want us to calculate these two following reactions enthalpies. Given that Br2 liquid vaporization, that is 15 kilojoules per mole, we don't want that for this one. You can go with this chemical cycle as well. First reaction, this second reaction, okay, ninth one. Last one. So MgBr2 plus Cl2 gives MgCl2 plus Br2. That is the equation they are asking. This is a question for question equation. Then if you have these three together, this is a formation of MgBr2 that we calculated from the first part. But as a data, they were given this one. So you can get the answer very easily. Or otherwise, you can go with the equation method as well. Both methods are there. Formation of MgCl2 given as a data, okay? Formation of MgCl2 given as a data. So this one we calculated. This is the part 2 data. This is the only unknown. Understood? Any question? Okay, this is again, we are going with these symbols. Pure liquid vapor pressures are saturated vapor pressures. And they were given molar masses, molecules, and moles. So you can find the Avogadro. Couple of molecules and moles separately. Knowing the Avogadro, you can fill all these. So they were asking these parts separately. So they were given these symbols, Na, Q, C, all those symbols they were given, they are asking us to write all those. Okay, I'm going with this little Total pressure given as H, and the temperature of the system given as Q. First one is the Avogadro number of molecules divided by number of moles. Okay, in that table, for number of molecules, liquid phase, they have given both A and B. So I'm going to divide number of molecules by number of moles so that you can get Avogadro number. That Avogadro number I'm going to use for second and third answers as well. Avogadro number, knowing the Avogadro number, then the second part, they want us to calculate number of moles of B in liquid phase. But we know number of molecules. Knowing molecules, they want us to find Q. Then A and A cancelling off, you can get Q. Here, same way, given that 3B, molecules, moles, molecules are asking C. Same, this one I'm going to substitute with that. Then you can cancel off this time, B and B. Then C equals 3A. Total number of molecules in liquid phase, A, B, C, 3 together. So that B plus 2B plus 3B. Now you have B and 2B and 3B. 2B we calculated, B and 3B given as data, 6B. Knowing 6B, and all those separate A, B and C number of moles, C, B and 2B and 3B, they want us to calculate mole fractions. That's very easy. Then partial pressure, saturated vapor pressure and mole fraction of liquid phase Raoult's law. P naught be given as a data, that is H divided by 2. Mole fraction we already calculated here. That's H divided by 6. Then total pressure, number of mole ratio equals pressure ratio. So that total pressure divided by B pressure equals total number of moles divided by B moles. So cancel off this. So you can get total pressure, total number of moles as 6B. Or either you can go with Dalton's law of partial pressure. You can get the same answer here. Then they're asking ABC mole fractions of vapor phase. Vapor phase. Total number of moles in vapor phase equals 6B. Here they have calculated, we have calculated that. Then B divided by 6B. That B they were given as a data, so you can go with that. And then here, to calculate A, okay, A over 3 is there. That is the number of molecules, but we don't know number of moles. To find number of moles, I'm using the Avogadro number. Because Avogadro number equals molecules divided by moles. Now I'm writing so that number of molecules divided by the Avogadro number is number of moles. Cross multiplication. So number of molecules, Avogadro number we calculated already. Then Na equals B over 3. Now we have both Na and Nt. Nt equals 6B. So that we can calculate Ya. Knowing this and this, only C is the remaining one. So you can calculate C, subtracting both those two by 1. So that is 7 over 9. Then 8th part, partial pressures of A and C, the same way. Total pressure multiply mole fraction of vapor phase. Total pressure multiply mole fraction of vapor phase. So the total pressure is given as H. And so PA equals H over 18, PC equals 7H over 9. PC. Then next part is volume. PV equals nRT. Number of moles is 6P. R is just writing. Temperature symbol they were given as Q. Pressure symbol they were given as P. And volume symbol they want us to get as G. So that this is the answer. They are just checking how much is your attention. Then no marks for this part. just starting from C squared by equals to RT over M. Only difference is temperature given as Q, molar mass of A. Molar mass of A given as L. Relative molar mass of A given as L. So that is the answer. Or even this way you can go, but this is the easiest way. They have given 5 marks only for this part. Are these questions harder? Saptara, Anuk, Amaya, Nadija. Not feeling like these are harder. If you go like this continuously, your exam paper you feel, and that's what these students like are the pan calling, and there are no challenges in the paper. So I'm waiting until you guys say that, okay? Moving to question number 6. Did I miss a part here? Is this part wasn't in the English medium one? Pardon me? Wasn't it there? I thought that I missed part of it. Moving on, they have this question. Okay, 500 cubic centimeter of aqueous solution has 90 ppm X shaken with 100 cubic centimeter of ether. Let's go to this answer because it has this explanation. So ether, so you lost the annotation. They were given ppm value per cubic decimeter, that is 90 ppm, but out of that 90 ppm, they were taken only 500. So it simply means total initial is 90 divided by 2, that is 45 ppm. Then they say once they've done this, once they evaporate this 100 cubic centimeter of ether layer, remaining X is 40, then only 5 is supposed to be remaining here. Then first part, they want us to calculate in ppm content of X in water obtained. For that, the best way is to finding this KD. So this is 40 and this is 5. Same molar mass, so I'm not going with the molar mass, but since two volumes are different, I have to divide by the volume so that KD equals to 40. See, 14 marks they were given for that. Then to find X in well water, that again they were saying ether layer has 43.2. That's in 100 cubic centimeter. Then in 1000, 432 milligrams per decimeter. Then I'm using this one to find how much is in aqueous, knowing KD. So this ppm divided by aqueous Q equals to 40. Manjula. Then subject aqueous layer X, that equals 10.8. Inorganic layer, they had 43.2. Manjula අපි next week එකේ දැන් හිටිය paper එකෙන් දෙකක් copy කරලා දෙන්න මේ දෙන්නට. photocopies දෙකක් ගෙනියන්න. next week එකේ මෙහි ඇවිල්ලා ලියන්න දීපු paper එක. So then 43.2 and this is 10.8 together is 54 ppm. That much is in aqueous layer. That much is in aqueous layer. That is a ppm. Multiply with 10 power minus 3 to convert this into gram. to convert into mole, divide by 125. So answer is 4.32 into 10 power minus 4. Again, the same data they are giving. Once you water, ether, now you have 6. In ether, 6. So the distribution coefficient is 40. From that, you can find how much is in aqueous. That equals 1.4. Here they have 6 in ether, 1.4 in aqueous. Altogether, supposed to be these two together, 7.5. Okay. Then multiply by 10 to the power minus 3 to convert grams. Divide by 125 to convert into moles, because this is the mole mass of X, and that is 6 into 10 to the power minus 5. So that මෙගොල්ලෝ එන්න වෙන්නේ නැහැ අර දෙන්නට විතරයි මේක එක විතරක් අමායටයි වදින්නේ ආන්සර් ෂීට්. So then they are asking us to explain this one. Well water has higher and treated water has lower. When treating with brick red, X is adsorbed, adsorbed onto it. That is the explanation. Then more reliable, repeat reading at each site. Wide, take readings at different sites. Repeating is reliable, wide, different sites. See, these are the marking scheme marks. I'll show this answer again just to go with marking scheme. Then the specification is filtered through brick powder until ppm value become less than 9. Filter to remove brick powder too. For that, they were given 5 marks. 5 marks for first point, 5 marks for second point. So, because it's drinking water, you cannot go with brick powder. Then you have to filter again with something to remove brick powder. Okay. Check your answer, how they were awarding marks. Just make sure whether you are losing any of these marks. If you need to reach 100 marks, make sure you're not losing any marks. Just the method, I will explain it. In 100, you have 43.2, then in 1000, how much? Then go with KD, that is the method. Okay. Anything from this page? With this. Okay, next time what you were supposed to do is, at the class, when you are doing the paper, you are going with exactly timing. Then rest of the question, least a sketch. Go at home, okay? So then you know all the questions when I'm doing. Because you don't know for the exam which question you're supposed to go through. Still you don't have that knowledge. Okay, this one, they have 3 different metals in the mixture, but they have forgotten to label how much is there. All these three containers are the PQR. They don't know what is the proportion. How do you find which one has highest and which one has the lowest? So they have done this experiment. They were taken 100 grams. It is 100 grams. They were taken 1 grams out. Okay, see, then they were adding HCl and check HCl once you add HCl. And it is making H2. If you fix a balloon here, the balloon is blowing depending on how much H2 is releasing. So if the volume is larger, it is releasing more H2. And if the volume is smaller, it simply means less H2. This is a balloon. Okay, so this is the calculation I have done. in 100 grams, if I go with the very first one. Anyway, I have this single one here. If you go with the very first one, aluminium is 21.6. That's in 100 grams. 100 grams, okay? 21.6. This is the mass. Then I'm going to go with this hydrogen, okay? So I need to find hydrogen. So I need the number of moles. So this divided by molar mass, that is divided by 27 to get number of moles. That's in 100. Then to get how much is in 1 gram, again I have to divide this by 100. This is for 100 grams. And I have to divide this by 100 to get per gram. And these are the three reactions. All these three are making H2. That H2 is the H2 which is using to blow this balloon. And the stoichiometry for aluminium is 2:6. That is 1:3. Sorry. 2:3. Here 1:1. And here 1:1. So knowing aluminium, I can find out multiply to I can find out hydrogen. Knowing magnesium, same H2 moles. Knowing zinc, same H2 moles. So I'm going with the very first one. 100 grams has aluminium, 21 grams. Then divide by the molar mass to get the number of moles. That's in 100 grams. But for the experiment, they were using 1 gram. So you're going to divide that by 100 to get 1 gram. Okay, in 1 gram, but how much hydrogen? Stoichiometry is 3:2, multiplied by 3, divided by 2. This is the hydrogen coming from aluminium. Number of moles of hydrogen due to aluminium is 0.012. Same way, number of hydrogen to zinc, 0.002. Number of hydrogen due to magnesium is this. So I'm going to add all these so I can get how much total number of aluminium is here. Same way I can calculate H2 coming from Q, H2 coming from R. And if you go with these three, this one is 0.04. That has the highest, 0.04. And then this is 0.03 and R 0.02. So the highest volume goes to the P mixture. Lowest volume is supposed to go to the R mixture. When you check the balloon size is the largest and here balloon size is the smallest. Amaya, got it. Any question? අනිත් අය දැනගන්න ඕන නම් දෙන පේපර් එක මොකක්ද කියලා ඒක නිසා අනිත් පැත්තට. Question number 6, and easy one. They were having this first one on chloride, second one chloride, common ion. How is this question now? This is KSP given, which X and X squared. So X is the solubility or the Sila plus concentration. And they are asking milligrams per cubic decimeter. You convert this into milligram, so you can get milliliter. But here the difference is Y, and Y. But still in the medium, you have now excess sodium chloride 0.1, 0.1. So Y plus 0.1. Since Y is very, very small, we neglect. So that Cl minus become 0.1 because Y is very small. I was just adding all these together, but you guys know they were given marks for this assumption, okay, in your syllabus. So that here Cl plus equals Y and Cl minus equals 0.1. 1. Now you can calculate solubility. 1 into 10 power minus 9, and again multiply with 142.5 to convert this into grams, multiply with 10 to the power 3 to convert this into milligrams, then value is 1.425 into 10 to the power minus 4 milligrams per cubic decimeter. If you done this, correct your answers. Otherwise, write answer so that you can do this at home and check your answers. Anyway, luckily, everything I'm doing is not missing. I think that is another reason that students are getting higher marks whenever you feel like you want to refresh something. You can go with recordings. Okay, so these are sort of out of syllabus, but I'm doing that. We did very recently. I guess you have the memory, you don't have to go through the question to understand this. Okay, so the next part, they want to quote silver on a copper ring. So quoting mean depositing, depositing mean reduction. Then the copper ring supposed to be the cathode. Quoting mean reduction, reduction mean depositing, depositing mean reduction. Okay, then the other side supposed to be silver anode, and the solution can be silver plus either A or B. See how they were given marks. Then electroplating mean you are coating anything electrochemically or this using these electrolysis on your cathode. Then they say they are saying fine and shinier the metal coating obtained would be if the rate is lower. To lower the rate, so we can decrease the concentration. So the solution is supposed to be solution B. Silver plus aqueous concentration is less. Since reaction rate is proportional to electrolytic concentration, rate of B is less, so silver deposits slowly. Next one is again same. So this is more stable than free silver plus. Then this reaction is moving more to backward, and silver plus concentration is less. That's why same thing again happening. Stability of silver cyanide complex is higher compared to free silver plus. Therefore, silver plus concentration in the medium is less. Therefore, rate of deposition of silver plus is less. Therefore, silver deposits slowly, uniformly, and finely. Silver mirror is again the same thingy, exactly same as the silver cyanide, silver amine complex, because we are adding ammonium silver nitrate. Silver amine complex is again more stable. See, here, since the silver amine complex is more stable, sorry. Okay, so that this silver amine complex is more stable, so that this reaction is forwarding more to right direction. Again, free silver plus is less. Since the complex formed is stable, silver plus concentration is less. Therefore, it decreases deposition speed of silver. Therefore, it gives the fine layer of silver to obtain silver mirror. Okay, since we were done with electrochemistry, I guess this part is now easier for you guys. Faraday's first law. discharge amount is proportional to the current passing. So that M is proportional to IT. To remove the proportional sign, we are adding electrochemical equivalence, which equals to molar mass divided by valency into Faraday constant. All the data given. So instead of this E, now I'm writing M over VF. Molar mass of silver 107. Current 0.15 ampere. Time given in minutes, multiply it with 60 to convert it into seconds. Valency of silver plus. So it's 1. Faraday constant. Then again, Coulomb equals ampere second. So that answer is 0.399. It's that easy. Then the last little part. Here again, this little point is really important. If you go with the question again here, the electrode potential of silver plus electrode becomes more positive as the concentration of silver plus in the electrolysis is increases. More positive mean cathode when the concentration is high. Who has the higher concentration, A or B? A has the higher concentration. So that just underline here, more positive. I have written it here, more positive. This A plus, you can write X here. Just X here, X here. So more positive mean cathode. More positive mean cathode. So the higher concentration is more positive mean higher E naught, that is the cathode. So higher concentration has A, low concentration B supposed to be the anode. Low concentration B supposed to be the anode. So that you can draw this way. Okay, so A is the cathode and B is the anode. Then negative silver anode, positive silver cathode. This is the solvage. See how they were given marks. Next part is again an extremely easy question. They were given this. You should know that barium hydroxide going down the group solubility is high, aqueous, cadmium sulfate aqueous. Then these two are given that KSP values. Knowing KSP, you should know barium sulfate because they were given KSP. So barium sulfate is supposed to be sparingly soluble. Cadmium hydroxide KSP given mean this is sparingly soluble. Otherwise, you don't have like the external knowledge. This one you already know, but you don't know much about cadmium hydroxide. Anyway, now we need barium sulfate separately, cadmium 2+ concentration, hydroxide concentration. They were given barium hydroxide. Barium hydroxide exactly equals to barium 2+ concentration. CV of barium hydroxide given, total volume, number of moles divided by volume is the concentration. Knowing barium 2+, they are supposed to be OH twice, see, OH2. So that hydroxide is supposed to be twice of that. And then they were given also cadmium sulfate. So cadmium sulfate to cadmium 1:1. CV of cadmium sulfate. Now they were mixing with barium hydroxide 100 and 100, so it's 200 now. Cadmium to sulfate 1:1. So that same concentration of barium 2+ as well. Now we need to make this barium sulfate. See, I have barium here. This is a barium. And sulfate here. And this is sulfate. Multiply these two together. Then I need cadmium hydroxide. Cadmium I have here. See, this is the cadmium. So this is cadmium. I have that. Hydroxide I have here. Multiply these two. See these two multiplication. Then compare with KSP. KSP 10 power minus 10, ionic product 10 power minus 9, so no precipitation. Here KSP 10 power minus 14 and ionic product 10 power minus 15. KSP is greater, I mean the ionic product is less, mean ionic product is not enough. So calcium hydroxide does not precipitate. Question number 8 is easier. M is 3D transition element. A stable dioxide MO2 white dioxide that we did have our background experience, that's supposed to be titanium. So M supposed to be titanium. So its atomic number is 22. 1s2 2s2 2p6, 3s2 3p6, 4s2 3d2, 4s2 3d2. Uses of metal and its oxide. Metal, aircraft body, stainless steel, TiO2, cement paints, and white pigments as a photocatalyst as well. Photocatalyst, like used as catalyst. Okay, then the next part. The test performed on a solution prepared by dissolving 3D metal. Naming solution S. These are the observations. Sodium hydroxide, blue-green. Not sure, maybe chromium. Sodium hydroxide and H2O2. This is the chromium identification test. So precipitation is not sure, but the yellow filtrate is chromate. Concave Cl, yellow solution, chlorido complex. Okay, precipitation is here, and chlorido complex is yellow, and passing H2S, acidic H2S, because concave Cl, acidic H2S, black color, that's supposed to be copper sulfide. Then this precipitate is supposed to be copper oxide, and this blue is supposed to be chromic hydroxide. So you have to go like a couple of times back and forth to get these answers. Understood? Okay. These are like, you know, the kindergarten work now. We did all this when we were doing classified. Anuk, we were doing explaining everything for classified. Anuk, drink little water. Try to be awake. If you feel sleepy, don't sleep. Get up, go around, just do something, come here. These 4 is like more than precious, like, you know, the stones or diamonds or whatsoever. Try to overcome whatever it is, okay? See, everything I did this way, that's for giving you guys the 100% understanding. But now you guys have this memory and everything. If you have this good memory, it's not necessary to go like this. Understood? So you're supposed to get the answer, not wasting your time on that. See, if you want, you can go through this one at home, like looking at this one, you can get the idea. But I want you guys to stop thinking like this and improve yourself when you're doing full papers. If you still feel like you're not having this enough memory, then go through classified. Then come back here, back and forth. Whatever the question you feel like harder, go through classified and find a couple of those kind of questions. Do them and then come back. Okay? Then you're going to be all right. So Cr3 plus and Cu2 plus. B's yellow is chromate. C's yellow is tetrachlorido. Then they're asking these equations. Chromate dichromate conversion is asking. Then the solution is solution turns orange. Okay, this is how they were given marks. Check your answers with marks. If you have a full answer, then don't worry. If your answer is missing part, if your answer has a missing part, it simply means you are losing marks. Then complete that part. This is any of these. Okay, this is O. Either this one or this one of these plus this. Ammonia production, source of nitrogen and hydrogen. Nitrogen source A, hydrogen source petroleum, reaction of CH4O, C7H14 with steam. But they were not given marks for that. Petroleum 4 marks. Conditions, temperature, we have taken 450. That's more than enough for 50 degrees Celsius. But marking scheme is not that tough. Even 400 or even 500, they were given marks. Pressure, 250, but they were taken as about 200. Catalyst, iron ore, iron oxide. Catalytic effects, rate of forward reaction increases, rate of backward reaction increases, equilibrium constant, no change. That's all they're asking those. Then nitric production, manufacture of nitric by process, that oxidizing ammonia. Conditions, temperature is 850, pressure is 1 atm. Catalyst is platinum or platinum rhodium. We went with platinum rhodium. Households use of ammonia, disinfectant or cleaning agent, we can use like that. Then these reactions, copper oxide, we did these equations. Ammonia I2, ammonia sodium. In fertilizer industry, to make ammonium sulfate, ammonium nitrate, and ammonium phosphate fertilizers as a source of nitrogen, rubber to prevent coagulation. We are using ammonium hydroxide or ammonia. You have to target the way they have asked the question, but I'm asking you guys if they are not doing this, because question number 8 has part of unit 14. Then again, question number 10 is full unit 14. Now they are not asking that way. They are now limiting everything onto 10 question, okay, for our syllabus. So it's not that hard again. This is question number 9. Yeah. Question number 9 has this. They were changing this format continuously, I guess. Ammonia is the starting material production of sodium carbonate solid process. Other starting materials are asking process and everything. Okay, other starting materials are carbon dioxide and brine solution, carbon dioxide by burning limestone or calcium carbonate, brine solution, seawater, or sodium chloride from seawater. Sorry. Either you can write brine solution seawater or sodium hydroxide seawater. Then byproducts, calcium oxide, ammonium chloride, calcium chloride. Balanced chemical equations, calcium carbonate burning to give calcium oxide and carbon dioxide. Ammonia plus water, ammonium hydroxide. That is the ammonium input. To that, we are passing carbon dioxide to get ammonium bicarbonate. Then heat it to decompose to give sodium carbonate. Recycling of byproducts is, that's to get ammonia back. So that's why calcium carbonate become the byproduct. reacting ammonium chloride and calcium oxide. Ammonium chloride is coming as a byproduct here. Ammonium chloride. In this process, you are not seeing ammonium chloride. They were expecting this method or this method. But here you are adding sodium chloride here. Here it's not showing. So ammonium chloride is coming. That ammonium chloride is reacting with calcium oxide to get ammonia. Byproduct is calcium chloride. Two reasons why low temperatures. Low temperature increases the solubility of gases. You guys know this gas dissolution is exothermic. When you decrease temperature, dissolution is increasing. Decrease the solubility of sodium bicarbonate so that we can get the solid sodium bicarbonate. Industrial uses of sodium carbonate and sodium bicarbonate. Sorry. Give 3 important factors into the site of this industry. Remember the very first page of this industrial. Availability of limestone deposits and ammonia. Closer to sea to get brine. Minimize of the environmental pollution by ammonia and carbon dioxide. Minimize heat generation. Disposal of byproducts. Transportation facilities. See, you have to think and write those. That's why I don't want you guys to go with this question. Sodium carbonate for washing clothes, water softening, glass industry, sodium bicarbonate users, bakery industry, medical users in fire extinguishers. See, remember, even when we were doing theory, I was skipping this question. I really don't like this question. Anybody did this question? Okay, if you want answers, mass of chloride in 1 cubic decimeter of water, no point of wasting time on this one. 150 milligrams per cubic decimeter. Chloride concentration 0.0042. Chloride concentration in water for 1 drop of silver nitrate is 50 milligrams per cubic decimeter. Then they are asking nitrate or silver nitrate concentration 0.169 moles per cubic decimeter. Okay. Polystyrene, polyvinyl chloride, and natural rubber. These concentrate well. Have the memory together with me. We are doing 22 papers together, so you can improve the memory. Polystyrene, CH2, CH2, one hydrogen become benzene. Polyvinyl chloride, C, one hydrogen become chlorine. And here, natural rubber, this is the polymer and this is the monomer. These three are monomers. These are repeating unit and these are monomers. You have to memorize this. Give one simple test carried out at home. Distinguish between PVC and bakelite. Bakelite, on heating, this does not soften or decompose because we can heat at home. PVC softened by heating. This is thermoplastic PVC, bakelite, thermoset. Bakelite, thermoset. That's the reason. Question number 10 given again to write all answers. But that's an easy question. Yes. Question number 10 is easy. And they have these couple of these compounds. And to separate them, separately given, okay? So heating. Okay, nothing remain once heated. decompose, leaving no residue. That's ammonium carbonate. Then heating, then I'm going through, then I'm making oxides. Okay, I'm going through charcoal block test. Yellow while hot, white while cold, zinc oxide. No observation. Then cobalt nitrate, pale pink magnesium oxide. Again, no observation here. So that you are going with the flame test here. Yellow green or apple green, that's barium. And these are the reactions. This one again, that's why I've given all these things together into one single place. Guys, I want you guys to go like memorizing everything. You have more than enough time. I don't know how you guys have gone. Since your result is not that good in first shy, I want you to work like hell this year, okay? Going from S to A is not impossible. It's not impossible, Dhoni. There were students who were having 3 S classes first shy, but later they were in medical faculties. It's only the energy. Let's say you were not finding correct path. Now you have the correct path. And the minute what she said the last year, I was saying this everywhere. Remember that she said, and I was asking like, how do you feel more comfortable? She's like, she was the confident because she thought that she knew everything and she was in the good shape. When you are doing questions, you understanding how much stuff you missed. So continue to do questions from all these 3 subjects. Continuous questions only make you better. There are no other solutions. Give one compound containing sulfur, one containing chloride. A bleaching agent, explain bleaching action. Industrial production. For the industrial production. Okay. So I'm not explaining any of this. This is your short note. This is your short note. This is 14. This is inorganic energy. So just go with that. And here I see these are the preparation methods. I'm explaining everything here. This one they say they have these 2 antacid tablets. They both contain magnesium hydroxide and magnesium silicate. That is the one part. Then again, they are giving this another data in stomach juice of this patient. 100 cubic centimeter has 0.365. 100 cubic centimeter has 0.365 grams of this gastric solution. The total solution volume is 500. But still, they say in 100, they have this mass. Mass divided by mole mass is number of moles. Number of moles divided by 100 mean the volume is the concentration. So that's the concentration H plus. Then initial pH equals to, this is become 10 to the power minus 1. Initial pH is 1. Now they are asking, after you have taken 2 tablets, what is the final pH? Okay, 2 tablets, this equation not given, so but very easily you can go that magnesium hydroxide and HCl 1:2. This one they were given, that's 1:4. Okay. Then I'm going to go with magnesium hydroxide. They were saying per tablet, magnesium hydroxide is 0.087 per tablet. Then divide by the molar mass, and that is the number of moles per tablet. Then in 2 tablets, twice of that. Then for HCl, how much HCl? 1:2. This amount again in 2 tablets, you have to multiply these 2 to convert this into HCl. So this is the number of moles of HCl for magnesium hydroxide. Then magnesium silicate, mass per tablet is 520. Divide by the molar mass. So you get number of moles. But again, per 2 tablets, multiply by 2. This is in 2 tablets. But then that 2 tablets amount, For HCl, you have to multiply by 4. Then HCl in magnesium silicate equals NHCl for magnesium silicate is this. Now, HCl used for total become the addition of these two, 0.006 plus 0.012. That is the total. Then, but they were given as another data. This stomach fluid is 500. In 500 fluid, because earlier we calculated concentration of 0.1, it's 0.05. But now tablets were neutralizing this much. Then this is the remaining. That's again in 500 cubic centimeter. Then get the concentration. Get the minus log 10 of that. So that is the pH of remaining stomach fluid of the vessel. Is this clear? Okay, this is the way they have awarded marks. Marks for steps. That is the most important now. MCQs, 50 marks. Structures, marks for each. Sorry. 5 marks for each. So 10 marks. Essay, 7.5 marks for each. So 30 marks. 50 plus 20 plus 30 is 100. But instead of calculating, they are getting this 5 to 100 marks. Understood? 5 marks is 100. This 7.5 mean 150. So they are getting, see, 100 into 4 is 400. 150 into 4 is 600 plus 600 is 1000. Divided by 20 is 50. That's how they do the calculation. I don't know how they have given marks, but still, I guess maybe 40 marks for, I didn't know. But don't go like that. Because in our syllabus, 50 and 50, this is the convention of our papers. Maybe they were, these are the marks for saturation. So when you are losing 1 mark of structured essay and essay, it's altogether 20. So that's what I'm saying, like losing a couple of marks doesn't do that much difference. Like 5 marks, 10 marks, 20 marks supposed to be loose to get your final marks to 99. If you lose 40 marks out of essay paper, then your marks become 98 and so on. Understood? Be really aware and always proportionate your time and effort to marks. And when you are doing the papers, check marks. Whatever the, let's say higher marks for something, then more effort, more timing. Then let's say less marks, then just you can rush that part. Be really, really trickier. Next week on, since we are doing papers here, I can guide you with everything, all those things, because I'm time to time I'm coming to you guys, and then I'm discussing things with you, then your own challenges and everything. Not stop. Never do that. You're torturing your fingers. Okay. At the same time, I'm posting here the marking scheme in case, okay, these instructions, not necessary to go through. These are very old instructions. So I'm just showing these In case if you were feeling like just to have a little look at the marking scheme, sometimes they are having these alternative methods, especially for organic conversions and inorganic calculations and equilibrium calculations. They have different methods. Some of these I'm not going to go through because these are old methods. We did new method. I didn't give you guys these method. We did our new syllabus methods. Anyway, I'm showing this one. If you feel like that you want to go through any of these, then get a little idea. Finish. Okay. Do you want to discuss it? Here we are done. Okay, and online students, next day, I want you guys to discuss your this self-review. I want you guys to discuss self-review with me, okay? So the Wednesday is paper writing day, Thursday is the discussion day, and post papers on Saturday. You guys are coming here on Saturday, so you can collect your 2004 and 2007 papers. In case you feel like you couldn't be able to get to the class on paper writing, then request that paper today or any day. Manjula would print it for you guys. Okay, then let's stop the meeting. Bye. Take care, everybody. Books are night.